Hello, can you hear me? Okay. Yes, I have a very short presentation of enabling technologies behind this asphalt paving process control system. And but before it, I have one question that could be listed in this list. What is the meaning of real-time or instantly getted data from the construction site? What is the meaning of that data in this lean project management? That question can be also write it down there, I think. Maybe after the presentation. Okay, but in this project, the objective is to evaluate and find the most suitable mixture of wireless communication technologies to be used in different levels of road construction process information network. And we have divided these technologies in two categories: long-range wireless communications and short-range wireless communication technologies. They have different. They are going to be used in different things. So this long-range wireless communication at construction work site is going to be used like a straight communication link between actor. I mean, actor is in this process network could be a machine, truck, or some loader, or human actor, or some service in internet. The actor is the word what described all. And the long-range wireless communication can be the straight link from the actor to the service network, to the information network, or act like a divided communication link between actors and process information network, like a hotspot. And we are going to evaluate different technologies, especially WiMAX, flash OFDM, and also some cellular radio networks like GPRS. And we have now some prototype under construction, and I show that later. And this short-range wireless communication is going to be used a communication link between actors, or actor and some hotspot. And the meaning of hotspot is that this can be temporal. So construction site is moving. It's not a static construction working site in somewhere like a building. It's some time in the same location, but road construction is moving ahead all the time. And hotspot is also moving. And this short-range wireless communication is used to exchange information between actors, and perhaps actors to hotspot. And also where, for example, there's an actor like this machine where there's no straight communication link to any hotspot or to the information network. The short-range wireless communication is used to machine-to-machine or actor-to-actor communication to share data and exchange data between those. For example, updating the design data. Let's say this truck comes to the city and has the straight communication link, and the information process control network knows that it is going to that machine which is in that location, and that doesn't have a straight communication link. It can load the data for that and go near to the other machine and upload new design information for that. of course, there's a satellite, but in this phase, this is only GPS information. Okay, but the data link is not enough. There should be also more behind the scenes. And how the recent state of information process and control of process are handled effectively in process control system. And there's we are developing this deeply networked lightweight service platform. This has been used in different application area in apartment maintenance, this same kind of lightweight service platform. But this suits well also in this construction environment. This is not only one-way communication. This is not only a state of some truck to the process control servers or process controllers, process management. There's always another way, like this designing information, how these all peers, all actors in the construction site has the up-to-date information, what they has to do, what is their plan, what is planned they to do. So this is two-way communication. And we have started development with hybrid peer-to-peer messaging protocol XMPP. It is standard and gives some standard tools to make for example, software agents to offer some services like database services, services for human actors, services for mobile phones. And the real benefit of this XMPP is that the client side, the peer side of the service network can be very light. This communication is controlled by the central communication unit called server, but it is peer-to-peer communication. So actor of this network, they doesn't need to know the exactly address in information network of other peers. They just have to know the virtual address, or doesn't even that. They just bring own present send own present information to the server's platform, and that's enough. They got the data what is have to be sent to the pairs in some location what is came through GPS. And here's the first prototype what is under development. This is the machine module, and it's very simple microcontroller based model which has different interfaces, GPS, and some sensors like IR sensor for the measuring temperature of asphalt mass, and inductive proximity sensor for detecting the unloading detection of the mass. And also there's some information exchange interfaces, GPRS modem for the straight communication link to the information network, and nanonet TRX radio, which is radio technology, short-range radio technology. And with this machine model, we are trying to prove our concept of this asphalt paving process control, and we are looking ahead to have some good results of this. But the main message is that we are developing very lightweight messaging platform and which use different kind of wireless communication technologies in different level of this service network. And this kind of simply microcontroller based node, what they called in here, or mode called here in Berkeley, can be full size peer or actor in this service platform. Okay, thank you very much. And then those questions.
Any questions at this point? Or people kind of getting a little fried?
Okay, sir.
Which kind of experience you have actually from construction site using these automated messages?
Automated.
Machinery of development of examples. What are the experiences from the site? What are the people thinking you are using those messages?
Well, I know quite much what road grader operators like this, and they really like, because it's so easier. All the little things they have to be watching and being very awake. It helps really much. But also there must be a link from design to machine control, and designers have to know how to make models, and which can be transferred to the construction site.
So those machines, they are utilizing the data from design also?
Yes, true. Yes, that's an important part.
So there's a change in the design. How do you implement that in the model machine?
Yes, that is in some construction site there comes changes every day, so it's a big issue, and wireless technology can be very useful. The designer can send the new data to the machine, and this is one issue we have also studied in some of our projects. Basically, the design data it should come automatically to the machine, and if there are, in some large construction site there can be 50 machines, so it's impossible for some people to take a floppy disk and go to each machine. So it is a problem and it must be solved.
The development situation is so that it is not possible to design machine control models using product model software. There are different separate softwares for typically are developed by these machine control system manufacturers, the developers. Machine control modeling belongs to the machine control system. It's one part of it. But in future, it's very probably that Tekla, for example, will develop machine control modeling capabilities into the product modeling software. Do you agree?
Back.
I think I'm misunderstanding the question.
Yeah. If you don't work with German finished product that could turn will be manufacturing machines. The product may also offer software. So getting design data to and from machines, yeah, it implements a two-way data process, which currently, our off-the-shelf products, we can take a design file directly from some type of software, whether it's a DWG file format, an XML, or some type of file format, and transfer it basically using the internet with 900 megahertz radios located on the job site and update the design files on all machines.
And then they can automate it, basically grade or excavate your plant.
So the design model and the machine model are more or less the same thing.
So the design model and machine model, with the exception of a format structure, yes, they are all DTMs. So they're a digital terrain model that once it's done, and the challenge is that those models, which I'll cover a little bit in mine, is that the models are not created from the engineering firms that way. So they're not 3D models. So from the engineering firms, what we're getting is a two-dimensional model. So we're getting a CAD file that has X and Y coordinates, but there's really no elevations to it. There's no 3D model to it. And so then that falls on the shoulders of the contractors that now have to say, okay, well, to utilize this technology, I have to back up and reverse engineer what I was given from the engineering firm. And that re-engineering is rework and time and adding more overhead. So that's part of the discussions is, hey, how do we drive the engineering community to give us the 3D models? If we get the 3D models, we can go right out in the field with them. So it's just a matter of a format change to accept whatever the machine control systems is or are and what type of formats they recognize. Does that help answer the question? And if anybody wants to see examples, I mean, I've got a presentation after a while, but if you want to see examples of what it is, I'll power up my laptop and show you. So.
And I think on this